Let me move along on the outline here. I'm not going to finish all this part to Roman numeral 3b. I actually want to move on to Roman numeral 4 here and give you a real world situation with exactly the situation I'm describing here. In 1998, a long time ago now, but not too long in my academic life, I did one of my asthma educational programs, an 8-week program, and since it was just the first one, I only had 6 people. And I measured their asthma quality of life before the program and did it again after. The survey that I had included statements like, during the last 2 weeks, I have had shortness of breath. And so 1 would be occasionally, 3 sometimes, and 7 always. Of course, the purpose of the program was for those numbers to go down. So I wrote some scores down there. Can you see that? How many people do I have in the first version of this? Well, there are a total of 6 people. The first 3 people have scores of 7 in this example. The second 3 people have scores of 6. So what I did is I measured these 6 people before my program in this example and after. So I feel tired. Pre-scores are 7, 7, 7, 6, 6, 6. If I get a mean for everybody at the pre-test, it of course would be a mean of 6.5, right? And then if I took these same people at the post-test, I get scores of 5, 6, 6, 5, 6, 6, so the mean is 5, 6, 6. And so the question is this a significant improvement? Well, the treatment effect, could you figure out what the treatment effect is? The treatment effect is the mean of the pre against the mean of the post. So what is it here? 6.5, it's around what, 0.84 or something like that? You'll have to figure out the difference yourself there. But we want a large treatment effect, right? We want people to be a lot better at the end. What a previous researcher was able to publish here is they said if you're running a study and you have a treatment effect over 0.5, which this one is what, 0.5 plus what, 34, so 0.84. They said if you ever have a treatment effect more than 0.5, that your program is actually working well. So a previous researcher said that. So I've got example results in my data in table B here. So let's take a look. The asthma study in 1998. So I'm looking at treatment effects. Of course, what would I want for the treatment effects? I would want a large effect for the treatment. I would want large treatment effects here. And if you look at things here, look at that feeling tired. Do you see that 0.83? Do you understand hopefully where that number comes from now? That little example I did above. You want a large treatment effect. That's the numerator. So if you look at this, feeling tired has a pretty large treatment effect, doesn't it? 0.83 out of a 7-point scale. That's a lot of change. But notice the standard deviation there, 1.35. Do you want that number to be large or small? Yeah, you would want that number to be small. The standard deviation goes into that denominator, the standard error, the mean score. And the t-score here is 1.83. And notice what the probability due to chance is, 11. Would this be statistically significant? Well, hopefully you would answer no. This is not statistically significant. This result is non-significant. So what is the deal there? Well, the deal is we have a large treatment effect, but the probability due to chance that we're not statistically significant. What do you think the argument is on why this result is not significant? We lack what? We lack power. We don't have enough people in this study to really show it being significant. So feeling tired, I have a strong treatment effect there, non-significant. Look at the other one, the wheeze attack, same kind of idea. That one is another large treatment effect, still not significant. The chest tightness, look at that, 0.75, non-significant as well. Worried about the future, restriction in sports, none of those are significant. But yet the treatment effects are quite large. So the problem that most people would say that we have there is we have a lack of power. There isn't enough sample, only 6 people, to really show a significant difference. Now, if you look at the next page, I actually combined the results of the 1998 and the 1999 study. So there I had a total of 12 people. I doubled my sample size. Look what happens now. Feeling tired, the treatment effect is still the same, but look at the probability now. The t-score is 2.38. The probability of having that happen due to chance is 3.5 out of 100. Now I'm significant. Why am I significant? Because I increased my sample size. I probably got rid of a type 2 error, a miss, and thus I am significant. Wheeze attacks now, 0.72. T-score of 2. Probability due to chance, 0.041. Statistically significant. Same with chest tightness, worried about the future, and restriction in sports. So the key point here is that if you have a small sample size, you could get pretty good results for a treatment effect, but you might have a miss because you have a small sample size and you don't have enough what? Power. So power is the ability to have significant differences and to see them, and you need to have a decent sample size to really detect this. And hopefully this example makes sense to you. Thank you very much.